Hi everybody, today is Tuesday, August 2nd, 2022, and I'm going to do my second recording of the day, and we're going to work on another exercise. So we're going to start off here on the syllabus page, and as you can see, we have finished the first example of the basics grouping in our lasagna app. And so now this has unlocked 5 new concepts, and with it a bunch of exercises. And so I wanted to kind of showcase the UI here a little bit. So if you highlight your mouse over the anonymous functions title, you'll see that this is a concept, and then these are the exercises related to that concept. And so in this case, anonymous functions has an exercise called secrets. Bit manipulation has an example called secrets, and so this is one exercise related to 2 concepts. And then other concepts are like booleans, that has a thing called Pac-Man rules. Floating point numbers has a thing called freelance rates, and integers also is referenced in freelancer rates. So what we're going to do is we're going to talk a little bit about anonymous functions and bit manipulation, and then we'll get to work on the secrets example. So anonymous functions. Functions are treated as first-class citizens in Elixir. That means that named and anonymous functions can be assigned to variables. Named and anonymous functions can be passed around like data as arguments and return values. And anonymous functions can be created dynamically. Anonymous functions, in contrast to named functions, don't have a static reference available to them. They are only available if they are assigned to a variable or immediately invoked. We might use anonymous functions to hide data using lexical scope, also known as closure, or dynamically create functions at the runtime. Anonymous functions start with the reserved word fn. The arguments are separated from the body of the function with the arrow token, and they are finished with an end keyword. As with named functions, the last expression of the function is implicitly returned to the calling function. To invoke a function reference, you must use a period between the reference variable and the list of arguments. So here we go. So here we're going to have a named variable called function variable, and we are going to assign it a anonymous function. So it starts with fn. Param is the incoming argument, and then after the arrow token is the body of the function, which is just param plus 1, and then we've got the keyword end. So once you have that, you can invoke it by calling the named variable, which is function.variable, period, and then in parentheses, whatever arguments you want to pass to it. So in this case, we'll pass 1, and we will get the return value of 2. You can even use a shorthand capture notation to make this more concise. So variable equals ampersand, and then a parentheses, and then you get ampersand 1 plus 1. So this is a common format you will see in some like terse functions. So a lot of times, like when you are mapping a list to another list, it's very common to just do these like really shorthand anonymous functions. Personally, they took me a while to really get comfortable with, and I still feel like on occasion I'll probably get a little hung up on them. Just the format is just a little weird. But the ampersand and the parentheses basically define the kind of like boundary of the function, and then the ampersand 1 is basically just talk about the first parameter that is passed in. So if you had multiple parameters, you could do ampersand 2, ampersand 3, and so forth. And similarly, you can instantiate it just variable dot, and then whatever you're going to pass in. So that is anonymous functions. Let us jump to bit manipulation, which is another fun one. So Elixir supports many functions for working with bits, found in the bitwise module. Bitwise and, bitwise shift left, bitwise shift right, bitwise XOR, bitwise OR, bitwise not. Here's an example of how to use a bitwise function. Bitwise.bsl 1, 2 returns 4. All bitwise functions only work on integers. If you're running Elixir, you will need to require bitwise. So I gotta be honest, like for me, manipulating bits is not something that I do often. And even though I've got a small history of computer science, like, it's not something I'm comfortable with. And if you're in that case too, there is a link down here that kind of links you to the bitwise operators on Wikipedia that kind of talk about what this is, where basically you've got a decimal number, in this case 7, and it'll show you how this kind of math works. As I said, this is not my let's see if we can find what this an example looks like here. See if there's not. Well, I don't know. Oh geez, look at this. Like, how can you not get overwhelmed looking at shit like this? Bitwise shifts, left shift. Yeah, I mean, so you can see like a left shift is basically just taking this binary representation of the decimal number and just shifting it, 1 over, or right shifting it. I don't know. We'll see what the example has in store for us, but that is the really terse description of the bitwise about bit manipulation, and this is the bitwise module. So if you come in here, you can see a little bit about what all this fun stuff is. So with that, let's break into the example. All right, so the example we're going to be working on is called secrets. While completing secrets, you will learn 2 concepts: anonymous functions and bit manipulation. So in this exercise, you've been tasked with writing the software for an encryption device that works by performing transformations on data. You will need a way to flexibly create complicated functions by combining simpler functions together. For each task, return an anonymous function that can be invoked from the calling scope. All functions should expect integer arguments. Integers are also suitable for performing bitwise operations in Elixir. So we've got create an order, create a subtractor, create a multiplier, create a divider, create an ANDer, or create a function combiner. Wow. I don't know. I find these kinds of problems not terribly interesting or exciting. I don't know. I mean, I feel like if you're coming to Elixir and you've got a lot of other experience, maybe this is your jazz, but I don't know. It's not for me. So once again, we're going to download it and run it locally. So we'll go into secrets and we'll open this up in VS Code. And so we've got our implementation file. We've got the test file, and then we've got the README, which, yeah. I'll show you if we can get all 3 up. Can I get 3 up? Yeah. Got the README up there. Yeah, I'll keep it a little bit bigger. Okay. So this talked about the 2 topics. Create an adder. Implement secret.secretAdd. It should return a function which takes 1 argument and adds it to the argument passed into a secret add. So the use case at the call site is something like secrets.secretAdd2, and it returns this, and then once they call that, when they pass in 2, they get a 4. Okay. So the first thing is this is going to be accepting we're going to be returning an anonymous function, so we can pass that in. So the first argument of the anonymous function is going to be secret, and the result is secret add. So let's keep the bitwise stuff open so we can look at this. Bitwise and B and 2. I wonder if we can. Yeah, we already have that open. So band calculates the bitwise AND of its arguments, that and that. So it should generally be something as simple as it should return a function which takes one argument and adds it to the argument passing thing. Oh, okay. So this is going to take X. That's going to take secret. So is the order adds it to the thing, argument passing that secret add to. Let's just try this. So adds it to the secret. So we'll say this starts with secret and it comes in with X, and it's going to complain undefined function b and that's because we need to include it. This was warned about in. If you are running Elixir 1.9 or lower, you will need to call require bitwise at the beginning of the module in order to. This should be a higher version of Elixir. We'll do it and see if that resolves our. Actually, we could just do. We'll just do that. Yeah, we'll just call the module names explicitly. I don't want to go into what require really does yet. All right, and so let's run our test. We'll run test at cursor. See how that works. So this failed. It failed. Let me make this a little bigger. So it passed in 3. It expected to get 6. And instead it got 3. Alrighty. So what is this problem? I don't think that makes a difference, but we'll try. Alrighty. Yeah, that's the same one. Secret add 3. Am I thinking? I think I might be getting the instruction wrong. Secret add. It should return. You know what we'll do? We'll show. Does this have the? I want to start it in the editor because I think the editor may have. Yeah, they got hints. So return an anonymous function which adds the argument from an anonymous function to the argument passed in secret.add. Okay. That's what we are doing. See, it seems unfair that like they just make this assumption. I know what like binary addition is like here. Oh, are they not like it's a return a function which takes one and subtracts it from, so they're not even doing binary stuff. Why am I? Oh, we're not even to the bitwise stuff yet. I am jumping the gun here. This is just addition. Alright, let's try this. Alright. Clear that. I don't know why that doesn't clear. There you go. Line 8. There you go, it passed. Yeah, I have jumped the gun there. Alright, so let's try this again. So this should be secret subtract, secret multiply. These are going to be simple. Secret divide. Secret and XOR, yeah. That's where it's going to get a little weird. Alright, so let's run all of these. I'll just take a peek to make sure that oh, it looks like do. Oh. There we go. Alright, we got a lot of failures, but we got some passes. Yeah, secret add, secret subtract does not work. 6 minus 3. This is where I think we're getting the order wrong. So let us come back up here and we'll just make sure we get each one. Alright. Implement secret subtract. It should return a function which takes one argument and subtracts from it the secret passed in. Okay, from it. So we just got the order wrong here. So this is secret. And for consistency, let's keep this order consistent. Even though for obviously different multiplication and addition, the order doesn't matter, it'll be helpful. And so what I'm going to do here is we're just going to verify, run a cursor. So we'll verify all the secret stuff add works, and then we'll do subtract. And all those work. Secret multiply. All those work. Secret divide. Those do not work. Alright, what were you asking for? Implement secret divide. It should return a function which takes one argument and divides it by the secret passed in secret divide. Isn't that what I did? Create a secret. It should return a function which takes one argument and divides it by the secret in secret divide. Oh, well, make use of integer division so the output is compatible with other functions expecting its input. Okay, you want integer division. Alright, let's go here. Let's take a look. Integer division. Performs integer division raised an arithmetic exception if one of the arguments is not an integer. Cool. Alright, so we'll just do that. Integer dot div div. Oh, this is in the kernel. That means we don't need it. So, yeah, div x secrets. Alright, let's try this again. Secret divide. Run all test at cursor. And that was passed. So, what I want to mention here is this is kind of like part of an edge case where Elixir makes some assumptions for you about modules and like which ones are available. But these are part of the kernel. So yeah, so this page, okay, so this is a page that talks about integers. But you can look when we click on div/2, it takes us to kernel. So these are functions that are provided to us through the kernel module. And the kernel module is kind of a special case because the kernel module automatically makes itself available to all the code. So normally, and you can do this if you want, just for more clear expression of where this function comes from, is you could say kernel, and you could spell it right, kernel.div, and that's where it's coming from. But you don't have to do that because these functions are so highly used everywhere. The Elixir compiler will just kind of make an assumption that these kernel functions are just inserted available to you. So the standard community practice is probably not to list it. So we're not going to do that. But just so you know, that's where it's coming from. And that's why, yeah, that's where it's coming from. All right. So that's done. And now I think we've got our bitwise stuff. So create an and, or I love that description. Implement secrets.secret and it should return a function which takes one argument and performs a bitwise AND operation on it and the secret passed in. So this is showing you kind of a use case of it. All right, so once again, we're going to use an anonymous function, and we'll say x, and we'll put it on 2 lines because we like that. So this is going to be bitwise and doesn't matter. Takes one argument, performs bitwise AND operation on it and the secret. So I'm going to put x and then the secret because I believe that's the order that they want. I'll put my cursor here. We'll run test at cursor. And those look like they work. Cool. So these should be similar. XOR. Let's see here. X. Or no, binary. Binary XOR is what we want. And we'll validate that those still work. Well, those work. That still work. Those look good. And then we've got our last one, which is secret combine. Create a function combiner. Implement secret.secret combine /2. It should return a function which takes one argument and applies it to the 2 functions passed in to secret combine in order. Here's where we're getting the complexity stuff. So we're going to create a reference to store this function that comes out of secret multiply. We'll store this here, and then we'll do secret combine. What does combine mean? It should return a function which takes one argument and applies it to 2 functions passed into it. Combine. Is that a... I mean, I don't think they mean the bitwise and like stuff. Secret combine. What do they mean by the word combine? I know what's going on here. So they got secret function 1, secret function 2. It should return a function, so it is going to return a function, which takes one argument, that, and then returns and applies it. It should return a function which takes one argument and applies to it the 2 functions passed in to secret combine in order. And applies to it the 2 functions. I'm struggling to understand what they mean by the word combine there. I assume they mean addition. Try it. So we'll say function 1, we'll pass that in, and then we'll do secret function 2, and we'll pass that in. I don't know if that's it though. Run test at cursor. Yeah, that's not where combine. Yeah, these are all failing. Let's take a look at what these look like. 5, add 10, then subtract 5. So it creates secret add 10, secret subtract 5, secret combine F and G. And so 10 so when you call H5, it's going to do 15 15, and then this is like one of the cases, and this is something I experienced working through these examples in the past, was just like I found the requirements to be not clear. 5 add 10, then subtract 5. 5 add 10, then subtract 5. Oh. So when I call h.5, that's the first 5 in that test description. And then it adds 10, and then it subtracts 5. So this is just weird. This is like, I mean, it's tough because it's so abstract. It's like, well, like, if I got a PR with this in it, I'd be like, what the hell are you doing? Like, why this is not clarity. This code lacks clarity. So F is capturing the function concept of secret add 10. Maybe it's like inner. Like, the very first thing we do is this anonymous function is passed an argument. The very first thing that we capture is secret function 1. We pass that in, and then we take the result of that, and then we pass in secret function 2. That might be what they're looking for. So we'll run test tick cursor. Yeah, that passes. Wow, that is just that is not fun. I mean, it demonstrates the tools, but that is just, I don't know. That is just weird. Alright, well, for verification, we'll run all the tests in the file. 22 tests passed, 0 failures, 0 skipped. That looks good. Is there anything we want to improve here? So one thing we're not doing with any of these examples is we're not writing documentation. We're not writing type specs, which is something you'll learn later, which is how you can kind of describe the intent of the argument. So you like, I intend this to be an integer. It's not something that's forced at runtime, but anyway, that'll come later. We're not writing any of that stuff. These are very bare bones modules. I think we're good with that. And these could be one-liners, but I kind of like them on multiple lines. And this could be, we could use pipes for this, which we haven't really learned yet, so that's why I'm not going to use it here. But I bet when we look at the community solutions, that's going to be there. So we'll do exercism, what was the command? Submit. And this will be secrets. And we can view it there. Great job. Cool. So this is our iteration. Looks like we're all done. No recommendations or anything of that nature. Let's take a peek at the community solutions. Yeah. All right. So one thing we can see here is that they do it all in one line, which is nice and tidy, although I prefer the multiple lines. They also use the and kernel dot syntax. So in our solution, or my solution, I'm just using plus and minus and multiplication, just as you would kind of see it in a lot of other programming languages. But the important thing to remember here is that this is all functional programming. And so what's happening is at compile time, the compiler is turning this into something like this. Kernel dot minus thing, and then you've got x secret, which I guess is what they showed here. Yeah, or they got they got and one, so they're actually capturing the thing there. But that's what it looks like at a more realistic level. But the compiler lets us write it in the style which is probably more familiar to people. And unless you're doing it in a one-liner, then I think that's fine. So they do the bitwise stuff. Yeah, and they use pipes to solve this problem, which we haven't really talked about yet. And they're also using then too, which is a newer syntax available. But they haven't shown us that yet. And so I'm going to try as best I can to build solutions based off of the stuff that they have taught us and not jump ahead too much. And kind of see what a couple other people have done. Secret, function addition. Yeah, they're trying. I mean, I used X in my last examples, which I kind of complained about in my previous video. And they're trying to use more reasonable variable names, which I think is a good step. Yeah. And they got one-liners there. What are these people doing? Function, carry, sum. Oh, wow. What are they? Oh, they're doing real binary math in this one. Can people comment? Yeah, people can comment. Comments have been disabled. That seems complex. But alright. Cool. So I think we're going to mark that as complete. And we will share our iterations. And you've learned two concepts, anonymous functions and bit manipulation. I don't know if I've learned bit manipulation, but I did pass the test. So cool, we got some new green check marks. These two have not unlocked the list yet. Lists are still locked behind booleans. So those will come in time, and maybe we'll do booleans next time. So for now, thanks a lot for watching. If you have any feedback or questions, let me know, and I'll see you next time. Bye-bye.